Hello guys, welcome to another video on GD&T. In this video, we are going to explore datum feature modifiers. Now, these datum feature modifiers are a very important concept in GD&T. You can see them applied in all different types of industrial drawings, but they are often misunderstood and misapplied. So we'll understand what exactly are they, what is the meaning of when they are, what is the meaning of the drawing when they are applied, and how are they different to no datum feature modifier. So here is a comparative drawing between uh, basically the same part, but there are two different drawings over here. So the part is as shown over here. This is a 3D view. It's basically a simple lever which is having two holes, and it is having a width as shown over here 20 plus or minus 0.1. One surface is the primary datum feature A, which is having a flatness applied to it 0.05. Then this larger hole of dia 25 with the size tolerance of plus or minus 0.15 is being controlled with respect to its perpendicularity within a cylindrical tolerance zone of 0.1 with respect to A, which is the primary datum feature surface, the flat surface, and this is datum feature B, which is the feature of size, which is a hole. Then the smaller hole, size 13, is being controlled with respect to its position. The position of this hole is being controlled with respect to the position of this hole, and this is indicated by that. Feature control frame says that the position of this hole should be within a tolerance zone, a cylindrical tolerance zone of 0.15 at maximum material condition with respect to datum A and datum B. Datum A being this flat surface, datum B being this feature of size hole. So this is datum C, datum feature C. So datum feature A is a flat surface, datum feature B is a feature of size hole of size 25 basic, and datum feature C is another hole with a basic size of 13. And then you can see there is another feature control frame which has been applied for profile. So the outer profile, all around profile, is being controlled within a tolerance zone of 0.5 with respect to the datum reference frame A, B, and C. Now this is same for both the drawings. The only difference over here is that on the right hand side drawing, there is a maximum material condition modifier applied along with the datum B, which is a feature of size. So what does that mean? So to summarize the interpretation, flat surface is datum feature A, form control has been applied. Large hole dimension 25 is the primary datum feature, secondary datum feature B, and there is a perpendicularity applied to it which is relating its orientation to the primary datum feature A. Smaller hole is the tertiary datum feature which is located with respect to the secondary datum feature with respect to basic dimensions 82 and 0. 0 is implied because it is at the center, and position control is being applied to that. That is the datum feature C, and profile control is applied for the datum reference frame all round. So what this basically means is that this position control is applied in the condition that the part is being rested on primary datum feature A and it is located, it is constrained in its location with respect to datum feature B at maximum material condition. So when the datum feature B is at maximum material condition, the position control is 0.15. Whereas over here, there is no M modifier. That means that irrespective of the size of B, that is datum feature B, the position control 0.15 is applicable. Whereas over here, the position control is applicable at maximum material condition B. If the size of B, that is this hole, is not at maximum material condition, then there will be shift. That shift does not mean that the position deviation allowed of this hole from this is different, but the part itself, when it is being inspected, can shift. Another way to understand this is that the datum reference frame remains fixed on the left hand side drawing, whereas the datum reference frame is mobile. What do we mean by a mobile datum reference frame? It means that the point of measurement of the smaller hole, that is the center line or the axis of this hole, which is used as the measurement reference of this hole, can actually change. So the reference which is used to measure the position itself is mobile. It is not fixed. Whereas on the left hand side, this reference is fixed. Over here, this reference, the point from which we are measuring the location of this hole, is itself moving. So then the whole part will move as with respect to that. This is with respect to inspection. When the part is being inspected, the datum reference frame, the point of reference is stationary on the left hand side, whereas the point of reference is mobile on the right hand side. That means that there is a datum shift which will be applicable on the right hand side when measuring the position of the smallest hole. So the datum itself, the reference itself will shift, and based on that shift, the measurement has to be taken. We can visualize this datum shift using this example over here of this part being inspected. So this part is being rested on a datum feature simulator, which is this surface. This is the datum feature simulator for datum feature A, and then there is a pin, the green color pin, which is being inserted. That mating pin is inserted into the large hole, which basically locates this part. So if the mating pin is the same size as the size of the hole, then the part cannot move around, does not have play, does not shift. It is stationary in terms of location. We're not talking about orientation because this datum reference frame is not fully constrained. It can still rotate about this point, but we are talking about the position of this part. That position of the part will remain fixed when the mating pin for this part is the same size as that of the hole. So there is no gap, there is no clearance between the hole and the mating pin. Hence it cannot shift. Whereas if the mating pin is made at a fixed size, the point of reference will shift, and this is called as a datum shift. So when the mating pin is at a fixed size, it is not the same as the size of the hole. When the hole size is larger, then the part can shift in inspection. This is the meaning. This is datum shift. So you can see this is the shift. It can move around. So this moving around is datum shift. And when we are using the datum feature modifier, then and that part is going for inspection, then the inspection has to be done based on that datum that feature control frame, and that will create datum shift during inspection. So if we look at the functional gauge for this part based on this drawing, it will look something like this. So the part is first rested on top of the datum feature simulator for A, that is based on this surface. This surface is rested on the surface plate, and then this green color pin is inserted. This green color pin has a fixed size, and that fixed size is basically calculated based on this feature control frame. And then this pink color pin is inserted based on the basic dimension shown over here. This pink color pin is inserted, and if this pin is going through cleanly, then the part is okay, and this is called as the functional gauge. And you can see that in this functional gauge, when this pin is being inserted, there is datum shift. This part can shift around, and we can move around this part and then insert the pin. So that basically validates the position of the smaller hole with respect to this hole, which includes the datum shift. So the main purpose of this functional gauge is to check whether this pin, this pink color pin, we will be able to assemble it or not into this part, considering the datum shift. So that is the purpose of the functional gauge, and the design of the functional gauge will be done based on the drawing. And when there is a datum feature modifier over here, then the size of the pin will be fixed for this. So that allows the datum shift. If there was no modifier over here, then this pin would be variable, which means that whatever the size of the hole, this pin would match that, and hence it would not allow the datum shift. But since this is used, this pin size will be fixed for inspection. Hence it can allow datum shift, and the main purpose is to check whether the pin will assemble or not. A very important point over here is that datum feature modifiers do not change the positional tolerance between the two features. So the position of this hole with respect to this, that allowable limit does not change when there is datum shift involved. That remains the same. Only thing is the reference itself is moving. That is what datum shift is. Thanks a lot for hanging around and watching this video. I hope to create many more videos in GD&T and tolerance stackup. It will really encourage me if you like, subscribe, comment and share this video. And also check out other videos on my channel. I have plenty of videos on GD&T and stackup and courses as well. I'm basically working on creating a learning platform at school-macademic.com where I have plenty of courses and many more videos on topics related to design engineering, ranging from concept development, design process, manufacturing process selection, the whole array of topics which are required for design engineers, including GD&T and StackUp. So check that out. Here is the link, school-macademic.com. You can check that out. Thanks a lot and see you in the next video.